Building apps in the cloud is complex, and that's to say the least. Organizations have to keep track of many different components, from your public cloud control plane to containers, databases, and to web apps. Modern applications can be gold mines for adversaries, rife with security gaps that expose entry points for threat actors to ultimately exploit. One of the biggest sources of app vulnerabilities is the development lifecycle itself, with vulnerabilities often stemming from human error, misconfigurations, or components of common pre-built packages. Hi, I'm Mark Guevara. Welcome to the latest edition of Under the Wing. Today, we're going to show you how the CrowdStrike Falcon platform delivers unified application security to help you protect your cloud workloads across the entire application development lifecycle. Now, if you're interested in learning more, use the link below to request an in-depth demo. Now, let's get started. Organizations today are under immense pressure to move fast, continuously racing through build, test, and deployment cycles. But being agile doesn't mean you should sacrifice or compromise on security. CrowdStrike helps you tackle app security from build to runtime through our cloud-native application protection platform, or CNAPP. CNAPP brings CrowdStrike's adversary-focused approach to application security, providing unified visibility, threat hunting, and remediation across your cloud and Kubernetes workloads. It does this by combining cloud security posture management, cloud workload protection, and cloud infrastructure entitlement management, all in a single unified solution, eliminating the need to juggle multiple tools. CNAPP also integrates seamlessly into your CI/CD environment to scan for changes in the infrastructure, automate tasks, and block insecure deployments. So let's dive in with Dimitri on how our CNAPP capabilities work through a demo.
Thanks, Mark. At CrowdStrike, we focus on integrating security into the CI/CD pipeline. As part of the functionality of CrowdStrike's Falcon Cloud Workload Protection, customers have the ability to create verified image policies that will ensure that only approved images are allowed to progress through the CI/CD pipeline and run on their hosts or Kubernetes clusters. In our first step, the developer will commit the code to the repository, which will trigger the code pipeline. In step 2, our pipeline checks our repository, which contains instructions on how to build the container, scan our image, install the Falcon sensor, and publish the image to the Elastic Container Registry, or ECR. Let's jump into the AWS console to take a look at what is contained within our repository in more detail. All the code is stored in the code commit web app repository. The web app repository is a collection of folders and build specification files in YAML format. The app folder contains our Docker file, which specifies the operating system and web application packages that we want to deploy, in our case, Ubuntu and Tomcat respectively. The CrowdStrike image scan folder has the instructions on how to scan the image. The sensor imaging import folder has the instructions on how to install the Falcon sensor. And lastly, the Falcon build spec file publishes the non-vulnerable image to ECR. Once our build is triggered, code build will build our image and scan it for vulnerabilities. In our example, the web app build failed as the code has known vulnerabilities. If there are any vulnerabilities found within the image, code build will send the scan report to the Falcon UI for review the complete list of vulnerabilities found. If we navigate to the Falcon UI, we can see the report and the vulnerabilities that were found within the image. You can access this by going to Cloud Security, Kubernetes and Containers, Image Assessment and Vulnerabilities. However, if there are no vulnerabilities found, code build will publish our image to ECR for deployment in production. In our second example, the web app build passed as there were no known vulnerabilities found within the code. The image passes our security check and is published to ECR and made ready for deployment into production. The role of code pipeline in all of this is to automate the steps required to release the software changes continuously. The tighter the integration between security and the pipeline, the earlier that threats can be identified and the speed of delivery can be accelerated. By seamlessly integrating with AWS CI/CD pipeline, Falcon Cloud Workload Protection allows DevOps to prevent the deployment of bad code, respond to existing vulnerabilities in code, and remediate incidents even faster, all by using the tool sets they already have. And with that, I'll pass it back to you, Mark.
Thanks for the examples, Dimitri. To find out more about how the Falcon platform can protect your organization from advanced attacks, and to start a 15-day free trial, go to www.crowdstrike.com.